Day 842 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1927 sum game. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Alice and Bob take turns playing a game with Alice starting first. You are given a string num of even length consisting of digits and question mark characters. On each turn, the player will do the following if there is still at least one question mark in num. Choose an index I where nums of I is equal to the question mark. Replace nums of I with any digit between 0 and 9. The game ends when there are no more question mark characters in num. For Bob to win, the sum of the digits in the first half of num must be equal to the sum of the digits in the second half. For Alice to win, the sum of the sums must not be equal. For example, if the game ended with the num string 243,801, then Bob wins because 2 plus 4 plus 3 is equal to 8 plus 0 plus 1. If the game ended with num equal to 243,803, then Alice wins because 2 plus 4 plus 3 does not equal 8 plus 0 plus 3. Assuming Alice and Bob play optimally, return true if Alice will win and false if Bob will win. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input num equals a string 5023. The output is false. The explanation says there are no moves to be made. The sum of the first half is equal to the sum of the second half. 5 plus 0 equals 2 plus 3. So, in this case, there are no question marks, right? So, we don't have the option in order to change any characters. So since the first half of this is equal to 5 because 5 plus 0 equals 5, and the second half of this is equal to 5 because 2 plus 3 also equals 5, we return false because that means Bob will win, right? It says right here, for Bob to win, the sum of the digits in the first half of num must be equal to the sum of the digits in the second half of num. So, and it says right here, assuming Alice and Bob play optimally, return true if Alice will win and false if Bob will win. So in this case, since the sum of the digits were the same or were equal to each other, that means Bob will win, and that means we return false because Bob won. Now, just in case that didn't make sense, let's take a look at example 2, where we actually have some question mark characters in the input. So in example 2, we have our input nums equals a string 25 question mark question mark. The output is true. It says Alice can replace one of the question marks with 9, and it will be impossible for Bob to make the sums equal. So in this case, say Alice changes this to a 9, then 2 and 5 can never be equal to 9, no matter what the second question mark is. It doesn't matter. 8 might, or if it was an 8 might work as well, because if an 8 was right here, a 7 might work as well, because no matter what, the first half is going to be 7, right? So as long as there's something right here that is greater than or equal to 7, then these, or actually it would have to be greater than or equal to 8, because if this was 7, then this could be a 0. Or let me just show y'all over here, right? We just bring it over here. So if this was, let's break it up into the two halves. So we already know the first half is 7. If this was 7, then Bob can, if Alice made this 7, then Bob can make this 0, and then they'd be equal and Bob will win. But if Alice makes this 8 or 9, there's nothing Bob could do to make it equal to 7, right? Because he could put a 0, it'd still be 8. 8 does not equal 7. Or he could put a 9. 9 does not equal 7 as well. So he chose to put a 9. So since he chose to put a 9, there's nothing probably because it's just he's or she is playing optimally, and that's going to make it even harder than the 8 would, even though they both win. So either way, we're returning true because Alice wins because she was able to make it so that by changing one of these question marks, Bob could never, it could never be equal to the first half. Now, just in case that didn't make sense, let's take a look at example 3, where there is a question mark in the first half, which changes things now because Alice can change this over here, but then Bob could just change this over here. So let's go through it. In example 3, the input nums equals a string question mark 3295 question mark question mark question mark. The output is false. The explanation says it can be proven that Bob will always win. One possible outcome is, so let's go through it over here. This is the one possible outcome right here. Boom. Alice replaces the first question mark with 9. So now this becomes 93295. Then Bob replaces one of the question marks in the right half with 9. So let's just say this becomes 9. Boom. Then Alice replaces one of the question marks in the right half with 2. So boom, this becomes 2. And then Bob replaces the last question mark in the right half with 7. So then this becomes 7. And in the end, Bob wins because 9 plus 3 plus 2 plus 9 is equal to 5 plus 9 plus 2 plus 7, which would be 19. So, well, actually, sorry, it would be 23. 9, 9, yeah, it'd be 23. They both equal 23. This is 23, and this is 23, y'all. So, boom. I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we need to do is we just need to get the total number of characters in the string. So we'll say let n equal num.count. Boom. Then we need to convert each character into a double. If the character is a digit 0 through 9, we're going to convert it to its numeric value. If the character is a question mark, we're going to assign it a value of 4.5. Using 4.5 represents the average value of all possible digits 0 through 9, allowing the solution to determine whether the two halves can ever be balanced. So we'll come underneath this and we'll say let num equal num.map. We'll open up the brackets and we'll say $0 period whole number value dot flat map. Open up the parentheses and double dot init. Come outside of that question mark 4.5. Boom. Then we'll come underneath this and we're going to compute the sum of the left half and the right half. If the sums are different, Alice can force a win. If the sums are equal, Bob can always balance the game. So we're going to say return nums square bracket 0 dot dot less than n divided by 2. Come outside of that dot reduce. Open up the parentheses 0 comma plus. Come outside of that does not equal num square bracket n divided by 2 dot dot less than n. Come outside of that dot reduce. Open up the parentheses 0 comma plus. Y'all, let's go ahead and give this a run. Make sure it runs properly. Let's see. And we ran out of time. So let me just make sure. Let's see. Make sure the syntax is all good. Particularly this equal white space, it seems. Let's try this. I don't know what. I don't know what. Oh, sorry, y'all. I know what it is. This should be an S. Sorry about it. That should be let nums, not let num. So let's let this time out. Okay, boom. Let's try this again and see if that fixed it. Hopefully it did. It should have. Okay, and now we are missing a square bracket. So, oh, right here. And this is that white space that was throwing me off. Okay, boom. Now let's run it. See if that fixed it. Hopefully it did. Should have. It's not that much code. Okay, it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 74 milliseconds beats 9.09% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.